This week, we discuss protecting data in apps and protecting our apps from malicious data. In the news segment, Microsoft navigates a sharp curve on Patch Tuesday. Browsers continue to make the user agent friendlier to users. Back to Microsoft for a source analysis tool, then 10 practices for DevOps, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Make sure your team is prepared to fight off the latest cybersecurity threat. IT Pro TV is the resource to keep you and your IT team's skills up to date. You can stream IT Pro TV courses live and on demand, so there's no need to send staff to off-site training. Team subscriptions include Pro Portal, so managers have full control over your team's training schedule. Go to itpro.tv/ASW and use the code ASW30 to try it free for 7 days and receive 30% off your monthly membership. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM.
Welcome to Application Security Weekly. This is episode 92, recorded January 20th, 2020. I'm your host, Mike Shima. I'm here with Matt Alderman.
Happy Monday. It's a good day for San Francisco fans, huh?
It's a very good day, exactly. So we're going to have a good month, I think. And we're also here with John Kinsella, also in San Francisco.
Happy Monday. I actually missed the game. I was on a flight last night, so I'm hoping to catch up and watch it sometime today. How are you, Mike?
Doing well. I'm enjoying a day of 20s, so we're going to basically play 20 questions since this is January 20th, 2020, and which is also, I was trying to come up with some good segue into a Star Trek joke because it's the 20 is the character hexadecimal code for space, but I couldn't get there. So instead, we're going to have to go through some announcements. So join us at InfoSec World 2020, March 30th through April 1st at the Disney Contemporary Resort. Security Weekly listeners save 15% off the InfoSec World main conference or World Pass. Visit securityweekly.com/ISW2020 and click the register button to register with our discount code. Our next webcast is February 13th with Sri Sundaralingam, Vice President, Product and Solutions Marketing at ExtraHop, where we will discuss cloud-native network detection and response. Register for our upcoming webcast by visiting securityweekly.com, selecting the webcast dropdown from the top menu bar and clicking registration. So we don't have a guest this week, but we do have Matt and John here to talk about a topic of the week. We started this year off with privacy by design, and I kind of wanted to continue that theme with talking about, more specifically, protecting data and bringing in the security element into privacy and application security into this discussion. And two major themes I wanted to touch on today, given our time, are encrypting data and some various approaches to encrypt data, because that's one good way to protect it. But also remember that we as application developers or DevSecOps teams are also, in fact, protecting our apps from malicious data, from everything from as simple as SQL injection and cross-site scripting, the undying attacks of the OWASP top 10, to areas that are more subtle. And there, I wanted to talk a little bit about whether input validation is really the recommendation we should have been making all of these years from security. But before we get into that part, let's talk about protecting data. And I wanted to touch on one of the things, just encrypting it. So I think I'll use the example of the Capital One data breach that happened over the summer. And one of the aspects of it was a S3 bucket was exposed, but the S3 bucket, the data inside it, if I recall correctly, was actually encrypted. And not just with the default encryption available for S3, but the records themselves were encrypted. And I thought that was already a pretty good step and countermeasure when dealing with data in the cloud. So with that said, before I continue to keep talking throughout this whole conversation, Matt and John, two questions here. One, a leading questions a little bit. Have you heard of envelope encryption? And two, either using that or other architecture patterns, how have you seen companies or organizations protecting data in the cloud?
John might want to go first. He gets to deal with this a little bit.
I threw the technical stuff out there for you, Matt. Come on.
I have heard of it. It's funny how this has been used, at least from what I see over the last few years, right? When Amazon, I think Amazon was the first to bring out a HSM.
Yeah.
And that was sort of when this type of thing started picking up steam, right? Because it's the bigger problem isn't so much, at least to me, not just how you encrypt or what form you do. I mean, envelope encrypting is, I think, is a really decent way to do a lot of this. For those who don't understand, basically, it's the same, similar to the concept of an envelope, where you take whatever your messages or data, you encrypt that, and then with a key, and then you encrypt that with a root key. So it's basically a form of PKI around your data for storage, the way I think of it. So that's why my neuron went straight to HSMs. I'm seeing, I think, more folks use it. I mean, obviously, not as many as we would like, but I think it's picking up steam in multiple different formats. What I've seen last year really is a pickup around the software systems like Vault. So folks are aware of it and they're looking for solutions. And the problem with the HSMs at AWS, those bad boys are pricey. And if you're going to do this in production, you don't just want a single one. You need at least two, right, for HA. So I think that the pain point there is both implementation, standardization of an implementation, as well as cost.
Yeah, and the performance impact and the hits that you take in your application, right? I mean, here's the challenge at the end of the day, right? If I encrypt data, then I have to decrypt it to use it. And some people are worried about the performance impact their application is going to take when they're doing this encryption and decryption, right? Mm-hmm. And so then you come up with ways to get the data available to the application in an unencrypted way, which then potentially makes it vulnerable for an attack, right? So there's all kinds of trade-offs here. And this is where I think we're going to see some interesting evolution of technology that I would like to see is how can we do a more effective job of data encryption without some of the performance impact where it becomes just a standard way of doing business? I don't think we're there yet. I'm just curious what you guys are seeing. I know some of the challenges we had because we've all been in the Qualys shoes at some point in our career. Some of us are still there, right? And we know what we did from an encryption perspective and the impact it had to performance of the platform and what things had to do, but it was the right thing that had to be done at the time, right? And so I see a lot of people not going down some of these paths because of those potential impacts, but now we're leaving data exposed, right? So again, it's this trade-off kind of balance thing.
Right. I think that starting to call out what actually John and Matt, what you guys have called out already is price and performance. So it's one thing for the security team just to separately say, cool, encrypt all the data in transit, encrypt all the data at rest, and you'll be fine. But when you actually have to start paying for it, both out of budget and out of performance, the story doesn't quite become so good. And I think this is also part of that kind of meta conversation about having empathy and having DevSecOps and the idea that, oh, you mean you actually have to implement all these recommendations we've been giving you for the last 10 years or so? Well, we don't have budget for all of those. Well, maybe we can pay for 2 HSMs, but the operations per second it can handle are by no means going to scale. And so that is actually, though, what I think has been, these architecture patterns like envelope encryption, meaning that you can drop a key encryption key into that HSM, and then you could have a separate data encryption key that is the application is working on. And that data encryption key can be stored in memory, that's what you're using for per record encryption or something like that. And you can basically improve some of the performance characteristics without necessarily losing some of the security guarantees, as well as you also get some additional benefits. It suddenly becomes a little bit easier to rotate keys. and a little bit more mistake tolerant, we'll say, human mistake tolerant to rotate keys, because rather than having just one for all of your data, you can actually start to have multiple. And you can have per tenant keys, and which are good for environments like Qualys or other areas that are dealing with a lot of different organizations. So that's one of the things I thought was interesting. But I think to the other point, we see the AWS and GCP, for example, having pretty decent documentation on the background of how to work with their cloud HSMs to set up this type of scenario. But with the implementation still can run into problems. And there you have, again, from Google, because they've been doing a lot of work here, but a library like Tink that basically abstracts a lot of these crypto implementations and just says, here's how to encrypt, here's how to sign, use this library, and move on. And that way, in addition to hopefully being somewhat performant, we're going to avoid having a lot of just those implementation problems that continually weaken it. And I guess while I have my, sorry, go ahead, John.
Well, to sort of expand upon that, I think in the way I think about this, I think we've talked about this a little bit in the past. This is one of those things I really actually want the cloud providers to do really well, so I don't have to deal with it, like you said, just so I can, forget about it and go. As a quick story, I was at a whiteboard last week with a client, and we were sort of sketching out like what an architecture for something could look like. And I was hand waving left and right about the encryption and data storage side of things, both at storage and in transit on the wire, because I didn't want to distract the focus of the discussion to think about those things, but also because they can become such balls of wax, right? I wanted us to focus on what was the problem we were trying to actually figure out. How do you solve and draw that out? But it sure would be nice, if we could just say either checkbox, this is secure, and I'm dreaming a little bit here, but I think some of the cloud providers are close, or say, this is my data, this is how I'm going to access it. I'm going to trust and let them take care of it and hope they do the right thing with all those things you're saying about, tenant-based keys and then actually, customer-based underneath that sub-customer. That would be really lovely to see. But then, really, really briefly, comes back to once we do this, we start getting a little bit away from being portable between clouds, unless there's a standard for that, which again would be amazing. But I think many of us are starting to think about that whole concept of being portable between clouds as a bit of a marketing story anyway. So have a way that I can do this and do it really reliably and easily.
Yeah, I think I'm talking to some engineers dealing with HSMs. There's even, trying to interoperability and standardization even among HSMs and different encryption libraries is a bit not so standard as one might desire. But I think a little bit it's also what you were saying, and on the theme of 20, we could also sort of play 20 questions in the sense of threat modeling. Because if we say encryption at rest, what are we actually protecting ourselves from when we are building microservice architectures and even business-to-business architect APIs? And all of these APIs need access to sharing data. Encrypting the data at rest doesn't really matter when it's transiting all through the network. And sure, we can say we're using TLS even 1.3, but once the data goes from one system to another, that data is effectively plain text if it's being operated on. So we also have to keep in mind, as much as we're going to say and extol the virtues of encryption, we also have to know that it's also got its limitations. And that's where we also, on the side, need to start remembering authentication, strong mutual authentication, perhaps between APIs, as well as strong authorization and access to the data itself.
Yeah, so here's one of my questions, right? I mean, when you start thinking about this from a design perspective, do I need to encrypt every single piece of data? Maybe not, right? Do I only need to encrypt certain sensitive data elements? And maybe I don't have to operate on those data elements all the time. And if I don't, I can keep them encrypted and only operate them on maybe certain microservices when needed, right? So I think a lot of this has to start from a design perspective to say, okay, what data am I going to have? What data am I going to store? Then which data should I actually encrypt? I don't necessarily have to encrypt every piece of data. Certain things are publicly available. Maybe I don't need to encrypt it, but there is certain things that I do want to encrypt, right? So can you architect your data design to isolate sensitive data in certain areas to keep it protected, make sure it's not traversing in a microservice API architecture to be worked on somewhere else? And can I build a little more effective model that keeps me a little more efficient from a performance perspective and only take hits in certain places?
Yeah, I think that's starting to say, can you actually start to then even tokenize the data? So rather than passing around encrypted blobs and managing the keys, just say, here's the one area that we will have to store it. We're going to wrap it with some nice amount of encryption, and then we're just going to give you this basically what looks like a random identifier that just happens to be the one identifier that points to this data. But if you don't really need to operate on my email address, for example, you just need to know that I have one or need to pass around a token that says, should you ever need to access and send an email, just go over to this tokenizer service, give them this token, and then it will send off the message that it wants. But we don't need to have my email popping up in 5 different databases through 10 different microservices and having to be protected in each one. And just like you said, once you can start doing that, then you don't even need to either worry about encryption and under what attack models or threat models it's actually protecting you from, nor do you need to actually incur the performance overhead of protecting it, because just exposing some random identifier isn't the same as exposing my email address, for example.
Right, and this is where we saw this with credit card data, with PCI tokenization, and in creating a token for the card number. If you leverage that same approach for other things like an email address, like a social security number, like a whatever that you want to protect, now I can architect my application in a way that's pretty unique and doesn't expose a lot of data in places it doesn't need to be, and then I'm more secure and I'm not encrypting everything.
No, absolutely. And I think then it also starts to get into that idea of, and we've touched on this a lot of other times, so maybe I'll just talk about it briefly, but logging and monitoring within your application. You do want to make sure that you're seeing who's accessing this data, but you're also logging all of these APIs, all of these services that are talking to each other. And if you accidentally, in a error dump, if you accidentally expose that token, that's a lot less impactful than accidentally exposing that credit card number. Because once you do that, then PCI is going to come down pretty hard on having violated, what the intent is of that compliance.
Yeah, exactly right. Now, let me throw the curveball in here, because now we've got machine learning and artificial intelligence into the mix. So everybody wants to take all of their data and all their data models and throw it into this big data lake. And now they want to play with all that data because they want to improve their models. Now we've created a very interesting scenario where what we did to protect exposure at the application layer, we now potentially expose over here in our research, our ML, and our AI models. And that's where I've seen some really interesting potential technologies start to emerge, where maybe you can encrypt and protect that data, work on the models. There's some different solutions out there that allow you to do that in a more protected way to protect the underlying data. But that's the other challenge I see is, even if I architect the app right, somebody in the research group's going to want to try to pull it all together and throw it into this ML AI engine. And now we've got this big pot of potential data that could be exposed if we're not putting the right protections on that.
Yeah, and that's going back very much to that idea of you can't even encrypt it at that point either, because you can protect it with encryption, but it needs to be operated on in the raw. And so that's where there has to be a lot more clever design and architecture into the access controls onto that system. And can you even then start to slice data and have metadata labels on it, just describing different models are allowed access, or this type of data can be consumed by these models, but not by these models. Or here is something that is more descriptive, and maybe that's actually what the model needs is that descriptive aspects of the data rather than the underlying data itself, or not. But then we go back to that idea of our privacy by design discussion and what we need to do to protect manipulation of all of this.
Yeah,
so
exactly right.
I'm not positive this is a good idea. I'm thinking on the fly here, just sort of random thought. I wonder if anyone who is working with in that type of space where you're doing, you need that data set for ML training from production. If anyone's building into their production APIs, an API call like give me 500,000 records for training, that part of the main code would then, it wouldn't keep the token, but it would tokenize and export instead of people grabbing the raw data and doing it themselves. It seems like it wouldn't take long to write that extra bit of code. You wouldn't want to put too much of that load on production, but it seems like that could be an interesting way to sort of keep things sane.
I know there's been some interesting work in differential privacy and other types of privacy protecting queries, in the sense that here are some proofs developed to say within this particular data store, you can make up to n queries. So let's just say you can make up to 1,000 queries, and it's relatively difficult to de-anonymize any of the data. But once you get to that 1,001st, that data starts to then, it becomes a lot easier to work to identify that needle in the haystack. And so those types of designs I've seen work on. I don't know how pervasive they are. And I'm also going to do a little bit of hand waviness on the math to figure out, how much confidence we have in those types of models on top of the APIs to say, here is access to the data. You can only query it so many times before it gets remixed, reshuffled, and then you can query it some more times in privacy preserving methods. So I know there's nascent work, but by all means, I couldn't point you to anything public or open source around that.
And here's the real math problem when we get to the end of this. 10 to 15 years from now, all of our encryption standards will be completely ineffective against quantum computing. So, we're going to have to come up with a whole new set of encryption algorithms to deal with what's probably coming over the next decade plus on the quantum computing side, because, the ability to crack the current encryption standards we're getting closer every single day.
Yeah, a lot of that's going to definitely be that the public-private key setups are the ones that are the most susceptible to that. And that's what's going to be interesting around identity and basically what's NIST going to start saying. So when they update SP, 863, talking about digital identity, I guess that's the one to keep an eye on as they iterate on that and to see resistance to and algorithms to emerge. But I do want to perhaps switch here, because we were talking about encryption, and so here's something that's recommended by security teams: go encrypt data, protect your data in this way. And we've seen different trade-offs already. The quick summary for those of you paying attention, there's price and performance that you have to worry about. Even though security just says encrypt all the things, it's not necessarily going to protect you from everything. But applications also need to protect themselves from data in that sense of, that I alluded to at the beginning, SQL injection and cross-site scripting. And that's where one of the most common recommendations I've seen in pen test reports, and the OWASP top 10 for that matter, is use input validation. But every time I see that, I kind of do an eye roll and think, like, what exactly does input validation mean? And is input validation even the best recommendation? Because I'm a bit skeptical that that's ever been a very useful recommendation, or it's been anything other than just a security mantra that people invoke and hope that it protects applications, and it doesn't really do anything necessarily.
Well, isn't it 2 steps? It's 2 pieces, right? It should be input validation, then parameterized SQL, right? Then I can control not only the input, but then I can control the parameters that I send to the query itself. So I think you actually have to have kind of both in place to really prevent or protect against it, because input validation by itself may not be the full answer. So I've always heard it as input validation and parameterized SQL calls. That way you can protect what's actually being inserted in the SQL statements.
Yeah, and I think what you're getting at there is the more specific context of just use those parameterized SQL, because then it doesn't matter what input is coming in. You can do some input validation just to, pre-filter a bunch of junk that is this doesn't match the format of an email address to use that, or this isn't a number, or this isn't this is a really, really long string of 10,000 characters rather than 100 characters. So that's SQL injection. The same with cross-site scripting. It's input validation isn't really necessarily the smart way to go about cross-site scripting. It's more about output encoding, because what is the context of where you're using the data? And that's really what I kind of wanted to open up here, highlight on this part of the discussion is, what are you actually doing with the data? Is it going into a SQL query? Awesome, parameterized statements. Is it going into a web-based front end or an email reader that has rich HTML? Perfect. Use the right output encoding for that and don't really worry about what the input originally was. And I wanted to broaden that too with the idea that in modern applications, there's a lot more user-generated content than just text. And so text is the threat for SQL injection cross-site scripting, obviously, but we also have PDFs. I bet you didn't know, or maybe you didn't know, that PDFs can actually have JavaScript support inside it, as well as images can have a lot of, going back to the idea of privacy, can have a lot of metadata in it, but images and image encoders and video encoders and decoders, those are notorious for having vulnerabilities inside them. So once you start to say input validation and dealing with images and videos, it's a lot less about, well, it's not a string, so what do I do about it? And that's what becomes, I think, is the more useful conversation to have from security teams about, hey, I bet there is a way we can use our cloud architectures to help you with these problems.
Yeah, I mean, files in general, right? You can have macros and other things embedded in Word files. You can have stuff embedded into PDF files. We've definitely seen some interesting image attacks over the past couple of years where you can embed some malicious stuff into images. So again, to your point, Mike, it's not just text. It's any potential thing that you're going to store. It could be in an object store database, for example. But there are vulnerabilities in a lot of these different types that you need to also check and validate for.
Yeah, I think, and we're going to talk a little bit about more about crypto in the news segment, but there's also the idea of serverless, for example, is one of the great use cases here for doing this type of, call it input validation or the user-generated content normalization or the sanitization. You can drop, if you're getting in random images and you don't need to preserve the original image, bit by bit, like you might in a photo site like Flickr, for example, which I think Flickr is still around. Poor Flickr.
Yep.
But you could also just then transform everything into a PNG, and that way spin up a serverless function, do the transform, or do the transform for that video into a particular frames per second or particular aspect ratio that you just want to serve for your site. And if that's, if there is a flaw in that decoder, that flaw probably isn't going to get access to too much additional information if it pops in, out of, or into, whichever the preposition you want to call, that serverless function. Because that serverless function you can spin up with the least privileges. It's going to be really difficult to pivot into some other data store. And it's really going to be difficult to pivot into a trusted and assume a trusted service. So the cloud can actually, I think, help us in a lot of these situations as well by using smart architecture, smart design.
Well, that's one of the things. Oh, go ahead, John. I don't want to.
Where I was going to go was, it's funny. So when Mike first mentioned, adding this to discussion, I was a little surprised. In general, I actually am a fan of doing some level of validation while you can, but I think it comes to the edge points, right? Of what do you mean when you say that? So I think some of those cases are pretty easy to capture. The first one that pops into my mind is like buffer overflow, right? I mean, you can usually guess that a string shouldn't be longer than, X characters, or you can make that assumption. But I think sort of cycling back a little bit to where the discussion has gone is really talking about being a little more mindful about compute, right, or programming. So what are you doing? How are you doing it? I'm taking input from a user. One of the first questions I like asking developers when going through doing a review is, do you trust this? Do you know where it's coming from? What are you doing with this data? Where's it going to go, right? So those sort of four things will give you a sense of where do you deal with these things. It's sort of like we were talking before about, do you encrypt all the data or not? Do you do input validation on everything, or where do you use it? But then the second part is it's those two metal questions I asked about. Once you get that data, what do you do with it? If you're doing some sort of manipulation with it, are you checking for errors upon response? Are you checking for null pointers? How are you handling it? If you hand it over to a serverless function or something else, if that serverless function crashes, in the forest, does anybody know at nighttime? So in other words, what are you watching your logs off that serverless stuff? I've been playing with some of the Azure functions, and it's interesting, to say the least, when you do and don't get logs back from your I've been tinkering with some JavaScript functions in there, so it could be a JavaScripty type things, but you start doing promises, the logs don't always get returned before the function exits. So what happened to someone was complaining, but where'd it go? So some of these things are things to think about, and it's not just so much not so much the data itself are you validating, but what are you doing with that thing once you get it?
Yeah, and that's a great, because you're starting to then plant that seed of 20 questions, that threat
Yeah.
modeling approach. What are you collecting? What are you going to do with it? How much trust do you put into it? And one of the things I would kind of, in response to that and try to add to that, is when we're talking about either the parsers or the open source software or the third-party software that we're using to manipulate and deal with the various formats of content we're getting that's user-generated. There's also the idea of, what about just reducing the feature set that this particular data format supports, or restricting things like XML entity XXE. That is an example that you might get XML data that needs to be uploaded, but your XML parser doesn't necessarily need to be making external calls. So reducing that feature set, if that doesn't break what you intend to do with your application, then by all means, just turn it off. And that's a lot of ways to then reduce your attack surface. So I guess part of what I was getting at here is that we can talk about input validation, but I think it's more interesting to use that as the step into that threat modeling discussion of, what in fact are you trying to do and where are you using this data? And then what kind of attack surface is this data flowing through? Can you reduce that attack surface? And then by that, you can worry less about the quote unquote 0 day, or something really nasty is coming in with the data, and have more confidence that there's a little bit less area to inspect, a little bit less area to theorize about of its security design.
Sounds like a good plan.
That'll buy. And there was an article I was reading earlier today. I think it's in the Times. We might cover this in news. We'll see. But it's talking about what's the name of the company here? Clearview, I think. Yeah, the guys down in Australia, and some fun stuff they're thinking. And it's basically, I'm sort of taking that up a level. What we're just talking about. We're talking about input validation on a particular input. But what happens about when that is, this can be used in your advantage in some ways from a privacy point of view, by just, garbage injection, so to speak, right? So sometimes if we're worried about our privacy, or we're worried about other things out there, I think you could almost make an argument that I'm going a little sideways here, but there's a point to it. I think in some cases you could make an argument that it's okay to allow some garbage into the system. How I respond to that versus how the founder at Clearview responses, that might be a little bit different. But it's what is, again, it comes back to what we're talking about, that threat model. What are we actually protecting against? Is someone else's face, is that an attack, or is that useful? I mean, that's a little more meta, I think, possibly, but still tied back to the discussion.
Yeah, I think what you're kind of opening up there, we can shift into another topic for the future, perhaps. But basically, adversarial attacks against AI or ML, or that's the shorthand wavy for your fancy if-then statements in your neural networks. But the idea that manipulating what data goes in can have a adverse effect, perhaps, against the model that's being developed. And even when Matt was talking about the model, we were talking about, yeah, you have these massive amounts of data. What happens if the data itself is perfectly valid in the sense that it is well formed, it matches the, it is an image of a human face, for example, or it is a text that matches an email address or something like that, but it is done, but it is manipulating the model behind it. So it's mistraining those. And I think that's an emerging area that we don't have an OWASP top 10 list yet for. So hopefully within the next 10 to 15 years, we'll get a cool OWASP AI ML top 10 list of ways to attack those types of scenarios.
But I think part of the reason I'm mentioning it there is obviously it's a little more in the media, a little more, I'll say, sexy to some of us right now to think about. But at the same time, for folks, when you're going back talking to either your developers or your management or things like that, this gives you a way to sort of back into that conversation, right? It might sound like a super nerdy thing to talk about, what is that, am I validating my input or should I be validating it correctly? But it gives sort of a use case for people to talk about something that's an analog.
Well, I think sets us up because I think we have a couple great super nerdy things to talk about with developers coming up in the news. So I want to say thanks, Matt. Thanks, John, for a great discussion. We're going to take a quick break and we're going to return with news of the week.